this video, we'll solve a few application problems with derivatives and integrals. So let's take a look at this example. Let v of t equals 10 sine of 2t. T is between 0 and 2 pi. Graph the velocity. Determine when the motion is in the positive direction and when it's in negative direction. Find the displacement over the given interval and find the distance traveled over the given interval. So, part A. Let's graph the velocity, right? So the velocity function is given by 10 sine of 2t. And we want to graph it between 0 and 2 pi. So when we have trigonometric functions like this, we'll discuss amplitude is 10, is the number that we multiply by sine. The period is, well, sine of t has period, sine of t has period 2 pi, right? We remember that from trigonometry. We have the unit circle, right, which is from 0 to 2 pi, or we have the graph that looks like this, right, and it repeats every 2 pi period. So, but in this case, I don't have sine of t, I have sine of 2t. So because of that, the period is going to be 2 pi divided by 2. So whatever number you have in front of t here, it's going to be at the denominator of the period. So the period is actually pi for sine of 2t. Now the scale, right, how we count, like for example here, this is pi over 2, and then this is pi, and then this is 3 pi over 2, and then it's 2 pi, right? It's each of these points here are the scale. So in our case, the scale is going to be the period over 4. So this is going to be pi over 4, and these formulas that I wrote here apply for any type of sine or cosine functions. So when we have something like this, now how do we graph it? Well, we go t and v of t. So the velocity, the amplitude is 10. So let's write 10 here in negative 10. The scale is pi over 4. So we go pi over 4, and then 2 pi over 4, which is pi over 2, 3 pi over 4, and then pi, and then pi plus pi over 4, so 5 pi over 4, and then 6 pi over 4, which is 3 pi over 2, and then 7 pi over 4, and then 8 pi over 4, which is 2 pi. And we stop here just because our t is between 0 and 2 pi. But if it was larger, we could have gone further. Now, let's graph it. Well, sine of 0 is 0. And now sine of pi over, or 10 sine of 2 pi over 4 is going to be 10. And so I'm just going to put here the points that I usually would put if I was graphing 10 sine of t, but now the scale is different. So when we graph, we get this graph here. So now, determine when the motion is in positive direction and when it's in negative direction. So in positive direction, it's all the way here, right? Positive direction above x-axis. So positive direction on 0 pi over 2 and on pi 3 pi over 2. The negative direction is below the x-axis or the t-axis. So is between pi over 2 and pi, and then between 3 pi over 2 and 2 pi. Part B, it says find the displacement over the given interval. So the displacement is actually integral from 0 to 2 pi of v of t dt. Or, well, we can calculate that integral from 0 to 2 pi of tan sine of 2t dt, which you can calculate using the antiderivative, negative cosine of 2t over negative 2, and we evaluate it. But we can also say, well, this area plus this area is 0 because it's the same area and one is positive, one is negative. This area plus this area is 0. So the displacement is actually 0. And so the distance traveled over the given interval. So c, the distance, so basically is the distance is integral from 0 to 2 pi of absolute value of v of t dt, which actually, if we think about it, is this negative, it's positive, and then this is positive. So we actually have 4 integral from 0 to pi over 2 of tan sine of 2t dt. So this is 40 negative cosine of 2t over 2 from 0 to pi over 2. This cancels with this, so we get negative 20 times cosine of 2 times pi over 2 minus cosine of 2 times 0. So cosine of pi is negative 1, cosine of 0 is 1, so we get 40. So while the displacement is 0, the distance is 40. Let's take a look at one more problem. So we have, let v of t equals 30 times 16 minus t squared, t between 0 and 3, s of 0 equals 0. Determine and graph the position function for t between 0 and 3. So this is a very similar problem with the problem before, only this time we don't have a trigonometric function. So s of t is equal to integral of v of t dt, right? Because v of t is the derivative of s of t with respect to time. So it's the derivative of the position function. So the position function is the integral. So we have integral of 30 times 16 minus 30 times t squared dt. So we get 30 times 16, 500, not 500, 480 t minus 30 times t cubed over 3 plus a constant, let's not forget that, minus 10t cubed plus c. But since s of 0 equals 0, we can say that c equals 0, so s of t is equal to 480t minus 10t cubed. This is the position function. B, how fast does the airplane travel in the first 2 hours? So s of 2, right, because s of t is how far it travels at any time t. So s of 2 is 480 times 2 minus 10 times 2 to the third. So if we compute this, we get 880 miles. And part C, how far has the airplane traveled at the instant its velocity reaches 400 miles per hour? So when v of t equals 400 miles per hour, let's find t. So we have, let's see, what is, so 480 minus 30t squared equals 400. So we get 30t squared equals 80, t squared equals 8 over 3. So t equals, well, it should be plus minus, but we use just the positive one, square root of 8 over 3, because it's time. So it's 2 square root of 2 over square root of 3, which means 2 square root of 6 over 3, and that is approximately 1.63 hours. So at 1.63 hours, the velocity is 400. Now, how far has the airplane traveled? We have to calculate s of 2 square root of 6 over 3. That will be, if we substitute here, 480 times 2 square root of 6 over 3 minus 10 times 2 square root of 6 over 3 cubed. So if we divide this, we get 160 times 2, 320, square root of 6 minus 10 times 8 times 6, square root of 6 over 27. And so if we compute this, we get approximate 757.17 miles. So this is how far it traveled. So a quick graph, right, of the position function. So the position function is this one. So between 0 and 3, we have, when it's 0, we get 0. When it's 1, we get 470. So let's say this one is 500, so 470 somewhere here. When we get 2 is 880, so this one, let's say it's 1000. We get something like this. And so the graph would be something like this. And for 3, what do we have for 3? 1170. So it's a little bit higher. So that's pretty much it, because we want to graph it between 0 and 3, including both. I do hope this helps.